Hello guys, welcome back to my last video. In this video, I'm going to talk about the last algorithm of integer operation, that is division. So this is question 13. Question 13 is a procedural knowledge question, right? So 4 divided by -2, I first brought out the negative sign from the divisor. So I brought out a negative sign from the divisor here. The equation right now is positive 4 divided by positive 2. And the semi-product here is positive 2, right? And then I place a negative sign back to the semi-product. The final product will be -2. Okay, then we move on to question 14. So question 14 is conceptual knowledge question. And I will start from a pattern model and then charge field model. Again, number line model cannot apply in the integer division. So in this part of the video, we will only introduce 2 models for meaningful instruction. All right, so let's start from a pattern model. Pattern model, we start for 4 divided by -2. I will start from this. We knew 0 divided by -2 is 0, right? And 1 divided by -2 can be write as -1.5. Sorry, -1/2, right? So here we found a small pattern. The pattern here is when dividend increase 1. The product will decrease by 1/2. Okay, the dividend increase by 1, the product will decrease by 1/2. All right, so based on this pattern, we can know that when dividend increase by 1, right, the product will decrease by 1/2. So here is -1/2 minus 1/2. The product here is -1, right? Okay, so here we keep following this pattern. We keep doing on this question. So 3 divided by -2. So 3 here is the dividend, and when dividend increase by 1, the product will decrease by 1/2. So -1 minus 1/2. That will be -1 and 1/2. And we can write this mixed number to improper fraction. It is -3/2. -3/2. Okay, so let's move back to our question here. So 4 divided by -2. So when dividend increase by 1, right, the product will decrease by 1/2. So the product will decrease from 3/2, -3/2, decrease by 1/2. Because here we have the same denominator, so the answer here will be -4/2, and we reduce it. The product will be -2. Okay, the product here will be -2 here. Okay, so it's still pretty simple by the pattern model in this question. Okay, let's move on to the charge field model. So charge field model in a division, we will do a little bit different from we use this model in the multiplication. So here we call it reversed charge field model. Reversed charge field model, okay? So before I explain question 14 by reverse charge field model, I first want to recall about two basic concepts of integer division. So the question here is, how do we interpret the meaning of 4 divided by 2 is 2? So in this equation, it can be explained by if we have 4 slices of pizza and want to share 2 slices to every people, how many people can get a pizza? So here I have 4 slices of pizza and I want to share 2 slices of pizza to every people. Okay, I want to share 2 slices of pizza to people. So how many people can get a pizza, right? So here I have first a group of 2 slices of pizza, right? So I have 2 group of slices of pizza. So 2 people can get a pizza, right? Because I want to share 2 slices to every people. So 2 slices to 1 people, 2 slices for 1 people. So the answer will be 2, right? So here the unit is people, okay? And this equation can be also explained by this. If I have 4 slices of pizza and want to share pizza with 2 people, how many slices of pizza can each people get? How many slices of pizza can each people get? Okay, so because we have 2 people here, so basically everyone can get 2 pizza, right? So the unit here is slice of pizza, and we call it group. So reverse charge field model will apply the concept about group. We use group as a unit in this model. Okay, so let's see how it works in the question. So let's get back to the question 14. Okay, so why is it called a reverse charge field model? That means we will think the solution by the opposite way. The question here is positive 4 divided by negative 2 is negative 2, right? It can be reversed as negative 2 times negative 2 is 4, right? Reverse. Okay, I do this again. It can be reversed by negative 2 reverse times negative 2 is 4, right? Okay, by this equation, let's record a rule when we use the charge field model in the multiplication. Negative 2 times negative 2 is 4 can be thought as I take away 2 groups of 2 neutrons from a neutral field, resulting 4 positrons remain in the field. Okay, so I take away, there's a negative here, right? In the multiplication, take away 2 groups of 2 neutrons from a neutral field. There are 4 positrons will remain in the field. Okay, that's a rule, and that's the outcome we get from last video multiplication, right? So back to the question. Positive 4 divided by negative 2 can be thought as how many groups of 2 neutrons? How many groups of 2 neutrons do I need to take away from a neutral field to maintain full positrons in the field? Full positrons in the field. Okay. Remember, I said concept of groups is used in this model at the moment, right? So I know that you may be a little bit confused about the sentence here. So let's do this way. So here we have a neutral field, right? And the question here is, how can I maintain full positron in the field by take away? So the question here is, how can we maintain full positrons in the field by taking away, okay? So because I have nothing to take away, right? So again, I will use the invisible pairs here again. So because I want to maintain full positrons in a field, so at least I will need 4 invisible pairs in the field, right? So here you can see in the field, I already placed 4 invisible pairs in the field, okay? And I want to take away 4 negatrons in order to maintain 4 positrons in the field, okay? So the question, back to the question, how many groups, okay, how many groups of 2 negatrons I have to take away? So how many groups of 2 negatrons? Here are 2 groups of negatron I already took away from the field, right? So that I can maintain the field as the 4 positron, right? So here we see this one. I took away 1 and 2 groups of 2 negatron from the field. Recall the rule, take away means negative sign, right? So take away 2 means -2, okay? Because divisor here, the divisor here is -2. That means a group of 2 negatron, right? And how many group of 2 negatron I already take away? That's 2 group of 2 negatron, all right? So I know it's maybe a little bit confused, so I will do this question again, okay? All right, let's move back to here. So let's see the question here again. So we reverse this equation to this one. When -2 times -2 is equal 4. So that means we take away 2 groups of 2 negatron. We take away 2 groups of 2 negatron to maintain 4 positrons in the field. Okay, so back to our question. +4 divided by -2 can be thought as how many groups? How many groups? Okay, how many groups of 2 negatron? 2 negatron. This is how many groups? This is 2 negatron. I need to take away from neutral field in order to maintain full positron, right? Full positrons in the field. Okay? So I start from neutral field. How can I maintain 4 positrons in the field by take away? So I have here, obviously here I have nothing to take away from the field, right? So I have to use the invisible pairs. So because I want to maintain 4 positrons in the field, so at least I will need 4 invisible pair in the field right now, just like you see like this, okay? And I will take away 4 negatrons from the field in order to maintain 4 positrons in the field. That's what the question asks we to do. That's the question asks out what we to do, right? So I already take away 4 neutrons from fields and remain 4 positrons in the field. Okay. So the question is asked, how many groups of 2 neutrons that comes from the divisor -2? How many groups of 2 neutrons, right? So how many groups, the first groups of 2, the second groups of 2 neutrons are removed from field? So the answer will be here. I already take away 2 group, the first group, second group. And because I take away, right? That means negative sign. And I take away 2 groups, so I -2. So the answer here is -2. Okay? Okay, so this is question 15. Question 15 is a procedural knowledge question. Okay, so -4 divided by -2, I change this equation to +4 divided by +2. Okay, so the answer will be 2. Okay, so last question, question 16. This is a procedural conceptual knowledge question. So again, I will start from the pattern model. Okay, so kids knew how to operate the positive divided by a negative from question 14 that we just talked about, right? And right now they don't know how to operate a negative divided by a negative. So we can use this method to explain it. Okay, so we start from 1 divided by -2 is -1.5, right? Sorry, -1/2, -1/2, right? And then 0 divided by -2 is 0. So here is a small pattern we found. That is when dividend divided by 1, when dividend decrease by 1, the product will decrease by 1/2. Okay, so the third equation here, when a dividend decrease by 1 from 0 is -1, right? The product will increase by 1/2. So 0 at 1/2 is 1/2. Okay, the answer is 1/2 here. So let's keep doing this model. Let's keep doing this pattern. And -2 divided by -2, when dividend decrease by 1, right? The product will increase by 1/2. So when 1/2 here increase by 1/2, that'll be what? That'll be 1, right? So here the answer will be the answer for this equation will be 1. Okay, and let's keep on doing this until our division. Our dividend is from the -2 to -4. Okay, so -3 divided by -2. -3 divided by -2. So again, dividend divided by dividend decreased by 1. Okay, dividend decreased by 1. The product will increase by 1/2. So 1 at 1/2. The question is, what's the question? So the question will be 1 and 1/2. So this is mixed number, right? So it can be write as improper fraction. Improper fraction here will be 3/2. So 3/2. Okay, that will be the answer. And the reason I write down the form in the improper fraction here is because I want to let you guys see the relationship between each product. Okay, so by the improper fraction, you can see the connection between each product more clearly. Okay, so however in the test, if you can try to make all the improper fraction to a mixed number. Okay, so back to our question. So here we got -4 as dividend, right? So dividend decreased by 1 from 3. The product will increase by 1/2. So here we got 3/2 increase 1/2, right? So the denominator is the same. So what's the answer here? The answer will be 4/2, right? And we reduce it to get the final answer. That will be +2. Okay, +2 will be the final answer for this equation. Okay, I think here is a typo. I'm sorry. This should be +2. Okay, it should be +2. Okay, let's keep move on to the next question. Next model, I mean. Okay, so here is a reverse charge field model again. So the question here is -4 divided by -2 is 2, right? So again, we reverse it. This equation can be reversed by 2 times -2 is -4, right? It's -4. Okay. So by this equation, let's recall again the rule when we use charge field model in the multiplication. 2 times +2 times -2 is -4 can be thought as we add 2 groups of 2 neutrons to a neutral field in order to get 4 neutrons remain in the field. Okay, so add 2 groups. Okay, add 2 groups of 2 neutrons. So 2 neutron here is a multiplier, right? To a neutral field, result in 4 neutron remaining in the field. Okay, so let's reverse it back to the question. -4 divided by -2 can be thought as how many groups of 2 neutron is divisor, right? That I need to add in order to maintain 4 neutrons in the field. 4 neutrons in the field. Okay. So the same thing, I start from a neutral field. The first one, how can I maintain 4 neutrons in the field? By adding in. How can I maintain 4 neutrons in the field? By adding in. Okay. 4 neutrons in the field by adding in. So here we have to add 4 neutrons into a field in order to maintain 4 neutrons in the field, right? So I add in these 4 neutrons into the field. Okay, and the question asks how many groups of 2 neutrons. So one group, there are 2 neutrons in a group, right? So how many groups here? So 2 neutrons as a group. So here I will have 2 groups. I add 2 groups of 2 neutrons to a field in order to maintain 4 neutrons in the field. Okay, so add 2 here means +2, right? So that will be the answer for this equation. Okay, so this is a reverse charge field model. It is a little bit different from the multiplication that you use in the normal charge field model. But basically, it's the same. It's just like the same concept, but we just try to reverse it. Okay. So you can do more practice for this reverse charge field model when you do the homework 9. Okay, and I will give you feedback if you do anything wrong or make any mistake in the homework. All right. So the last page, this is just a small reminder for you. The homework 9 and reading assignment 9 will due by next Wednesday, okay? And you guys will take a post-test. You guys will take post-test on April 27th. April 27th, okay? In the afternoon at the same time as the previous test you did. Okay, so this is the last video of my meaningful instruction. Hopefully you enjoy it. And you can email me if you still have any question. So good luck for your post test. I will see you. Bye bye.